forget it like I did yesterday. For those who are going to watch the video, Brady asked about the first question, the first couple questions on the assignment. You're putting x is pi over 3 in for everything there and pi over 6. So they're a little bit tricky because we've got cotans and whatnot, but we just have to remember that, like, I'm going to go back here for a second and just go to a new page. So that had cotan of some angle. So let's say, okay, we're here, cotan of, let's say, pi over 6. So if you're asked to evaluate that, we know that cotan of any angle is 1 over tan of that angle. So this is 1 over the tangent of pi over 6, which is on your unit circle, which this one in this case is 1 over the square root of 3 over 3. Well, that's kind of ugly, so we would just say 3 over root 3. And for something like a question like on that assignment, if this ends up to be something that's not the prettiest, if it's got a radical in the denominator, but if this side also has the same radical, well, saying like, I have no idea. It should work out. Cos of pi over 6 over sine of pi over 6. Well, the cos of pi over 6 is root 3 over, no, pi over 6. Oh, yeah. Root 3 over 2. The sine of pi over 6 is a half. Well, that's ugly. I think I've done something. I need to go back and look at the actual question. Cos of x over sine of x for that. Cotan of pi over 6 is that. Rationalizing, that would be root 3, whoops, over 3. What am I doing? Verify for the work for the given variable. Cos pi, I've got those correct. Yeah. I'm doing something. Pi over 6. The tan of pi over 6 is here. It's 1 over root 3. 1 over root 3 over 3. I've got something that I've done mathematically incorrect. The tan of pi over 6 is... This is the idea. Now I'm perplexed. I don't want to waste your time with this sort of thing. Cos of pi over 6, because pi over 6 is here. And a half. I've got that done properly. Tan of pi over 6 is which is 1 over root 3, because the 2's cancel out. If I rationalize that, one over tan cos. What is up with this? It should work out. I'm not sure what I'm doing wrong, but I will come back to that at the end. But that's the idea, Brady, that we're supposed to be doing. I have messed something up. If someone sees my mistake.
So for like 2A, it's the same thing?
Yeah, it's the same idea. Hmm. Well, I mean, I can kind of cheat here. I know the tan of pi over 6 is 1 over root 3, and the reciprocal of that is root 3. So it does work out. I don't know what I was doing on the other side. 1 over root 3, it works out. I had a brain fart there for a sec. So what I want to do today, yesterday we went through some stuff with these identities, strategies, make substitutions. Usually you're going to put sine or cosine in for something, expand brackets and factor. Those are kind of similar. Separate fractions and common denominators. This is when we have products, and this is when we have sums or differences, and rationalize if we need to. So I said, let's take a look at the first few, try those at home. I'm going to go through these ones, and that's kind of it. That's just the same thing on another page. So I snipped all of these out. So this one, my kind of strategy is that's kind of the problem or thing that is an issue. I can make tan squared. Well, if tan of x or theta equals cos theta, I can do the exact same thing if I square everything. Those are all equivalent, so I can say sine squared, well, x cos squared x times this one stays sine x. There's nothing I can really do with that, so I don't particularly care. Leave the simple side. Those both cancel. My equal sign. And so now the left side is sine squared x. The right side is sine squared x. Left side equals right side, and we're good. And that's really as straightforward as that one is. And what we did kind of before at the beginning was looking at, okay, take this and express it in a simpler way. It's really the same thing. That's kind of one of the big things. Any questions with that one? That one should be fairly straightforward, I think. All right. 3 sine theta secant theta tan theta equals 3 tan squared theta. So I see a whole bunch of stuff here. Secant, tan, and tan squared all involve sines and cosines. So I'm going to do the same thing. That 3 in front, it's a number. Just leave it be. So I'm going to actually do both sides here just for kind of, look at the left side first. Can't do anything to the 3. Can't do anything to the sine theta. Secant is 1 over cos theta. Tan theta is sine theta over cos theta. So there's a couple of ways to finish something like this. I'm going to look at one way and then talk about something else in a sec. So we have this great big fraction. 3 times 1 is 3. Sine of theta times sine of theta is sine squared theta. The denominator, cos theta times cos theta is cos squared theta. Well, the 3 is, again, it's a constant. It just sits there. This bit here, the sine squared over cos squared, is tan squared theta. I haven't done anything to the left side. Do those two equal now? The left side now equals the right side. So that's kind of one way to do it. I also could have stopped here and said left side equal right side if I did one thing to the right side. Well, tan squared we know is, well, the 3 is a constant. Sine squared theta over, even though that looked like an O, it just felt funny. So I could say that at this point, left side equals right side. Technically, they're both correct. And that's one of the things with trig identities. As long as you make one side equal the other, sometimes you do a bunch of work to one side and nothing to the other. Sometimes you do a little bit as and looking at these and evaluating them, it's like, okay, it's not kind of hard if I was marking them. Like when you do something here, I'm going to be looking, saying, okay, are they on the right track? Do they have some idea? In Teams, I can give little bits of feedback and say, well, these questions are correct. Check this part. But in terms of what I'm looking for is, have you done most of it? Can you make these connections? If you stop here because you recognize that and you show this step, that's fine. There's most of these, there's kind of the common way to do them, and then there's every other way will work. Um, but you can kind of do different things. It's up to me to go through and say, oh, okay, Brady did it this way. He got here. He's good. The only other initials that I saw pop up on here were Kathleen. Kathleen might say, go down to here and say the left side equals right side. You're both correct. You both get the kind of proverbial check mark. So, any questions with that one as I ramble on? Oh, 1 plus cos, 1 minus cos, and we've got sine squared. Hopefully there's some of these that we actually have to do something to the right-hand side. Because so far we haven't really done anything. This is one technically I can do not much to that one. I've got brackets and I've got a squared term, so this one I'm going to expand. 1 times 1 is 1. Can you guys hear the thumping footsteps of a heavy-footed toddler? Because I can even hear them through these headphones. 1 times negative cos of x is minus cos x. Cos of x times 1 is cos of x. Positive cos of x times negative cos of x is negative cos squared x. Negative and a positive, those bits cancel. So I get down to here. Anytime I have a 1 and a sine, cos, tan, nope, I don't want to do that. I want to go back into my identities. Anytime we have that business, I'm looking for a Pythagorean identity. The simple one is, or the base one is cos squared theta plus equals 1. So I want to make this Pythagorean identity look like that. I can subtract and say sine squared theta is 1 minus cos squared theta. Therefore, I can take this, put it in over here. Well, now left side equals right side. Could you technically replace it up here and have 1 minus, well, technically x? The variable is kind of irrelevant. Could you say the left side equals the right side at that step? Sure. It depends on what you recognize. I'm generally not going to do anything to something that has a sine squared or cos squared or one function, regardless of what it is. But that's an example of having to expand. Oh, another expansion. Gonna leave secant.
So
Nope.
you like to flip the sides?
Pardon?
You like so you basically just flip the sides.
Kinda. You're trying to make both of the sides equal the same thing is ultimately.
Yeah.
So you can like for this one, I'm doing well the stuff in blue and then making that last step and saying this equals that. Can I do stuff to this? Sure. But I mean, you can say all sorts of different things depending on as long as your math, your algebra, because all of this is fundamentally applying algebra. The rules of algebra that you learn in grade 8 and 9, other than saying sine squared plus cos squared equals 1 and having different things. But yeah, you're flipping isn't the word I would use, but I think I understand what you're saying. You're trying to make one look like the other.
Yeah.
I think that's what you're meaning, that sort of
Thank
thing.
you.
Yeah, these, and I said it yesterday, and it's like this is one of the crappy things to try to do like this because these need practice and practice and practice and practice and feedback and okay, if we're in a room all together and you try some of these, I can say, okay, well, try this step next, try that step. And like it's most people just need to be nudged in the right direction, but it's really hard to do that. So this is another one that to me looks like a bunch of expansions because I've got that plus sign. Because who knows, things could kind of go a little wonky. I'm going to do one thing with this just because I know this also equals 1 over cos of x. That may be the easier thing to do because I've got tans, cotans. I'm probably, when I have tan, sine, and cosine, I'm probably going to put it into sines and cosines. But I'm going to multiply this out. Say tan of x times sine of x is simply tan of x times sine of x plus tan times cosine times tan times cotan times cos. So we have all of that. So my first step here is expand and then put sine x and cos of x because that's probably going to make things look a little bit better. Okay, let's go finger. Sine squared. No, where did you get the squared? Dummy. Sine of x over cos of x sine of x plus uh, sine of x over cos of x times cos of x over sine of x times cos x. So there's my next step. There's a 1 over here. This whole business, when you have tan times cotan, well, I've got a sine and a sine, and a cos and a cos. All of that stuff magically, well, not magically, it's math, disappears. Over here I have cos x and sine squared x over cos x. My third step, and I'm just going to change color here, I've got a sum. I want a not benom, a denom. So I need to multiply. My common denominator here is going to be cosine because, well, that's what one of them is. Cos x over cos x. Back to red. Haven't done anything to this side. Sine squared x over cos x. Cos times cos is cos squared. Which equals, no, well, yes, but does anyone remember what sine squared plus cos squared equals?
Tan squared, I think.
Nope.
Not plus, never mind. That's over. Never mind.
Yeah, no, that's the sine squared plus cos squared. Get rid of the ink. Sine squared x plus cos squared x equals 1. I want to switch pages, not there. So if I go down to here, sine squared plus cos squared equals 1. Well, that means I have 1 over cos x. Is that what we had up above? Now they both equal. Left side equals right side. And we are finished with that one. Okay, good. That's actually recording. So far, so good. No, that's not what I wanted. Now, if I do that, is it gonna? So I just. What? Oh, you dummy. What? Hello? Did I totally screw that up? Oh, cancel. Oh my gosh. You flaming moron. Hi. Sorry. I totally blew that. My apologies. Let's go back here. Idiot. Alright. So we're back. I haven't totally screwed anything up yet. Sorry about that. Oh, this one looks pretty. So the first thing I want to do here is expand the bejeebers out of this. So this is really sine x plus. So for those of you who forgot how to do FOIL or expanding, this might be a little rough, but this is fundamentally all this one is. All right. Sine times sine is sine squared x. Sine times cos is minus sine x cos x. Negative cos times sine is negative. Well, I'm going to write it the same way. Sine x cos x. Negative cos squared times negative cos squared is positive cos squared x. So there's our first bracket, which is sine squared x minus 2 sine x cos x plus cos squared x. So there's that first thing. Right-hand side. If I have one of a trig identity that has a number as one of the sides, just leave the number alone. Probably going to work out for the best. Let's go here. Sine times sine is again sine squared x. Sine times cos is now plus sine x cos x. Cos times sine is also sine x cos x. Well, that line was so not straight up and down. And cos times cos is cos squared x. In this case, I've got two positive sine x cos x's. Now we need to collect our terms. Positive sine squared x plus sine squared x is 2 sine squared x. Negative 2 cos x. Negative 2 times sine x times cos x is the same as positive 2 times sine x times cos x. That and that go away. Cos x, cos squared x plus cos squared x is 2 cos squared x. Well, I've got a common factor of 2. The right side is still 2. We know that. That's 1. 2 times 1 is 2. Does 2 equal 2? Most of the time. So far, so good. I think people are still here.
No, I ran out of space. I had to restart.
Oh, well. Running out of space is one thing. That's a long one in one sense for all of this. Like, that's just a whole pile of writing. Now, if you recognize that this goes to here and that goes to there, you can kind of skip that big, ugly, long step. And I kind of did that a little quick. Um, but that's one like that. I'm going to leave that there for a second. I should have brought something to drink down. Still don't understand how elementary school teachers do it every day. They deserve medals. Some people say high school teachers should get paid more because they have to deal with teenagers. It's like, no way. I wouldn't want to chase 24 or 5-year-olds. One is hard enough. So are we, anyone have any questions with that one? I just want to go up and look at the other 5. I don't want to, if anyone wants to do, would like me to look at any of those. Those are the last 6 that are there. I probably would have time to do one of those if anyone had a preference. Someone who doesn't talk much. Now, not that it's totally related. Somebody said Alyssa went to the hospital the other day. Does anyone know if she's doing all right?
Oh yeah, she's good. She
Oh,
had appendix removed.
oh, whoa, that's rough.
Yeah.
Oh, because it's like, how bad is it? Did she get the COVID? But I mean, having your appendix taken out sucks because it's, well, uh, I wonder. She could have had the same guy who took my gallbladder out. Um, Apparently, when I was in waiting for my gallbladder to go out, mine was needed to be done, but your appendix has to come out right away. Like there's no weighting or anything like that.
Yeah, I got mine when I was 8.
Your appendix?
Yeah.
Oh, so you got a nice little scar. The guy I grew up with.
You can't even see it anymore.
Uh, I an older kid in our neighborhood had his taken out, and he had a scar that was like I don't know 3 or 4 inches long. So he joked that he got stabbed. So does anyone have a preference for any one of these? If I do one more and then call it a day. If you don't,
Do number 10.
do number 10. Why number 10? Because it looks the hardest?
I don't know. It looked the most similar to our questions that we got, so I just kind of went with it.
Well, whatever works. This one, to me, oh boy. Secant over sine minus sine over cos equals cotan. Whoop, I did not want to do that. Let's see. How do I want to start this thing? I'm I know this is why do I want to keep putting a squared? There's no squared. Cos of theta over sine of theta. So I know I'm going to want something like that. I'm going to leave that alone for now. So this one needs a common denominator. The denominator between sine and cosine is the product of sine and cosine. So my denominator I want for now sine of theta times cos of theta. In grade 9 and 10, you do some fractions. And normally, when you're doing numeric fractions, you want the lowest common denominator. Fundamentally, you can do any common denominator as the product of the other two or the two denominators. So this one I'm going to multiply by cos of theta over cos of theta. So I have cos of theta times secant theta. This one I need to multiply by sine of theta over sine of theta minus, oh, come on, brain, sine squared. Yeah. So we have that is our first step. Da, 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 da. So I'm going to look at this piece here because I don't really like that secant in there, not S double I N. I think I see where we're going. Cos of theta is cos of theta. We're going to put that over 1 times secant is 1 over cos of theta. Oh, that helps because cos over cos is nothing. So 1 over 1 is 1 over. Oh, I see where we're going. 1 minus sine squared theta comes from cos squared theta plus sine squared theta equals 1. So co theta cos theta equals 1 minus sine squared theta. So I'm going to replace this with cos squared theta over sine of theta times cos of theta. If we have this bit here, well, I've got a squared and 1. That's going to cancel with that. So we're left with cos of theta over sine of theta, which if we remember from way up here, left side equals the right side. So if you want to practice a couple more on the weekend, I'm going to try to today, depending if I have time. I will go through and I'll update this file and I'll do those other ones so you can look at the answers. Um, I put a form out which some people have answered, and there's kind of some recurring questions on Monday. I'll talk about before we start doing any math, um, what we need to do, or because one of the questions is, what do I need to do to earn a credit? And different courses are going to look like different things. Some people may have the online quizzes that are graded, and yeah, that could be done, but if you do most of the assignments that I ask you to do and you do them mostly correct, I'm going to say you would have been able to pass the class in an actual classroom. I'll end up probably talking to Mr. Bellier, Mr. Gauntz, see what they're thinking about doing. Um, but it is up to the teacher. So if I see evidence, like I see a bunch of the same names on here every day, but there's also people watching the YouTube stuff. So if you do the assignments, and it's just do as much as you can, put as much as you can down, so I can say, oh, Brady did enough of them for me to say check. Carly did enough, check, because that's really it's they explained it's teacher discretion. Apparently, there's going to be a letter coming today from the district or department to your parents and you guys to explain a little bit more, and because they could change it and say, oh, you have to assign online quizzes and you have to do this and you have to mark stuff and all of that. And it's like, okay, that's going to be a giant pain in the butt. One of the things on it was, oh, kids should only try to get 2 to 3 credits this semester. It's like, wow, the kids that I have are not going to be pleased with that. You'll still be able to go into your other classes. Like, and there's a chance that you could sit here and watch all the stuff, do the practice on your own and not submit anything. You won't technically, if I don't see any evidence, technically I can't say, oh, you get a credit. But you could go, you're going to be allowed to take 12B, you're going to be allowed to sign up for calculus, and you could go and get the marks that you would normally get. Um, and marks are a bit of a thing. There's some questions about what's going to happen for universities, and I have no idea. It, you guys, I mean, it's some people said, oh, well, a bunch of kids are just going to retake the classes next year. And it's like, but they don't have space for some of the classes. It's like, I don't know. I know most of you would have no issues doing a lot of this. So if you can go back over, fill out the form. I got to figure out how I have to compile everything. Um, but it's just up here. You just click the link. It's really, do you want to get the credit? Yes, no, maybe. And I put a fourth one. I'm not sure. And then a thing for comments or questions. So you can do that. Uh, give a, that's not the one I want. Give those a try. And then after today, Monday, we might talk about some of these a little bit, but then we'll be done Trig and I'll try to put some stuff up on the weekend. We're going to go into transformations, which you've done. Well, we've talked about already with are trig graphs. So it's going to be a little bit different. We're going to do some stuff with just general points and random functions, but we'll get to that next week. We may slow down, and instead of doing every day, we might go to 3 days or 4 days a week because I don't want to overwhelm anybody. Is there any questions? If everybody's happy, I'll sign off and hope you all have a good weekend and no one else's appendix bursts. You good? Yes,
Yeah,
no.
thank you.
Thank you.
Thank you, Mr. McKay.
Have a good weekend.
Thank you.
Thanks, Mr. McKay.
No problem. You're welcome.
Thank you, Mr. McKay.
Thank you. You're welcome.